I believe I can fly.
Here is our model of an oxygen atom. Notice it has 8 protons in the nucleus.
Notice that the number of protons is shown by the atomic number on the periodic table. Again, the periodic table shows our element has 8 protons.
The other particle found in the nucleus along with the protons is the neutrons. Notice that this isotope of oxygen has 8 neutrons. When you add the 8 protons and the 8 neutrons, it equals the mass number, which is 16. For this model of oxygen, 16.
The atomic mass for this element is 15.99. Notice that it is different than the mass number. That's because the atomic mass is the average of all the isotopes of oxygen, and that mass number represents just one isotope.
Okay, if you count all the electrons in this atom, it comes to 8. See here, 2 electrons in the first shell, 6 electrons in the second shell.
Hey, that's the same number as the atomic number for our element oxygen 16. That makes this a neutral atom because the number of protons with the negative 2 charge is the same as the number of electrons with a positive 2 charge.
How do you know how many energy levels or electron shells our atom has?
You can tell our element has 6 valence electrons by the row it's in the periodic table. The way it goes: 1, 2, skip a few, 3, 4, 5, 6 valence electrons.
That's interesting.
Go.
What are the 2 numbers on the oxygen element on the right corner?
Well, that shows how many atoms are in each energy shell. The first one has 2. So there's 2 in the first energy cell. The second number is 6. So there's 6 in the outermost element energy shell. The outer energy shell can hold 8. Our element is in group 16, which makes it part of the oxygen family. Some of the other elements in this family are sulfur, selenium, and tellurium. The most important common traits of these family is that they all share 6 valence electrons.
Looking at the clear and neat key we've created in our periodic table, you can see that our element oxygen is a non-metal. It is in the gas state at room temperature. By looking at the clear and neat key we've included in our periodic table, you can see that our element oxygen is a non-metal. It is in the gas state at room temperature.
How do you know how dense our element is, you ask? Well, you can look at the periodic table. These first couple of rows are low density. The medium ones are medium density, and the ones down here are high density. Oxygen's up here, so it's going to be low density.
Notice the size of the nucleus. You can see from its nucleus size why this element's density is low. Our element is amazing! Here are some of the things that it's used for and some pictures to help demonstrate. Humans inhale 6 billion tons of oxygen each year. Oxygen is colorless, odorless, and tasteless. Oxygen is by far the most abundant element in Earth's crust. Oxygen is the first element in group 16. Joseph Priestley is credited with discovering oxygen in 1774. Oxygen can be produced for commercial use.
Do you know why our element has so many great uses? Here are some things that make it special and useful. 1% of the Earth's outer shell is made up of oxygen. Stars in our atmosphere are usually made up of oxygen. 2/3 of the mass of the human body is made up of oxygen.
Each hydrogen atom only has 1 electron. They are very lonely, so they want to bond with oxygen. Since oxygen only has 6 electrons in its outer shell, hydrogen says, "Can I come over and fulfill your outer shell?" Then oxygen says yes, and they have a full outer shell. are some interesting pictures of our element and how it is used. I will describe each picture. This is a tree. Trees release oxygen when they use energy from sunlight to make glucose from carbon dioxide and water.
This is water. Water is made up of oxygen along with hydrogen.
This picture shows the oxygen cycle from the animals to the trees to the sky.
When someone can't breathe, the hospital usually pumps oxygen into their mouth.
This is the sky. It shows that oxygen is everywhere that we are.